A runtime compatible database matches Postgres execution semantics. It literally behaves and looks like Postgres for the ecosystem of tools, frameworks, and your applications. Usually, the runtime compatibility is achieved by supporting all the previously discussed compatibility levels, namely wire, syntax, and level and feature level compatibilities, and by preserving authentication, transactional semantics, by supporting system catalog, Postgres error codes, extensions, and much more. All it means for you in practice that it should be a no-brainer to migrate an application from an open source Postgres instance to your runtime compatible Postgres database. So now let's check this in practice. I've prepared a special applications. This is an e-commerce application where you can buy different products, see recommendations, reviews, etc. Think about Amazon website. And at the center of this application architecture is GraphQL. GraphQL responds to your front end, to your users' interactions, and also GraphQL interacts with your database. So this application was originally created for Postgres, and right now I want to test it and migrate it to Cockroach, Amazon, and Yugabyte. So let's attempt this migration for Cockroach DB the first. That's the connection stream. We are starting this application in my local Docker container. Let's wait. Okay, GraphQL engine is started, but it reports an issue. Let's quickly check it. The issue reported by GraphQL engine says that pgcrypto extension is required, but it could not find it on the Cockroach DB side, meaning that Cockroach doesn't support extensions. All right, probably as a developer, I'm good. I kind of can update this part of my logic. I probably will replace Hasura GraphQL engine with something else, but let me try to load the schema of this application to Cockroach DB directly. To do that, let's go to the PSQL connection to Cockroach, and here I have a special command. So this command, what it does, it will load that script that is usually loaded by Hasura automatically. And when I load the script, you can see that the tables are created, some indexes are added, but some of the operations failed to complete. Namely, we were not able to create triggers. If you scroll down, also, if I keep looking, yeah, functions, stored procedures are not supported, and there are some other exceptions related to their S syntax, etc., and to the domain. Anyway, so that's more than enough. I don't want to rewrite my application from scratch. Let's no longer torture CockroachDB and switch to the Amazon Aurora and Yugabyte. So I stopped this container already. What I do next, I'm asking this application to use Amazon Aurora instead of default Postgres instance. Okay, we are starting this application. Yeah, looks like no any issues reported by the GraphQL engine, which is good. GraphQL engine recognized Amazon Aurora as a Postgres compliant database. So like Amazon Aurora looks like Postgres for Hasura. Okay, I think right now we are ready to move forward and load schema and data through Hasura into Amazon Aurora. For that, we need to execute these Hasura specific commands. Okay, we're applying everything. It will take some time to load the schema. And now we are loading the data. So the database for this application is really big. So it will take, a minute or so to load the entire data set. Let's wait. Excellent. It says that seeds were planted. For us, it means that all the data and schema were loaded and created. Wonderful. Let's quickly check that that's the case. I'm going to my Aurora connection. And if I execute this statement, let's execute it once again, you can see that there we have different tables created by this application. But most importantly, let's open this application. It's running on my local host. During the first request, Next.js that is used for this application is going to compile everything, so it will take some time. But now it's loaded, and we are serving all these products from Amazon Aurora deployed in the cloud. Wonderful. No issues. Without any code changes, I was able to move from open source Postgres to Amazon Aurora. Now let's try to do the same for Yuga by DB. So I am going back to this application container. Let me stop this container. And while the container is being stopped, let's ask this application to connect to Yuga by DB. Okay. Now let's start the same application, but with Yuga by DB. It will take a few moments to relaunch this container and initialize all the components from scratch. Okay, now I see that the container is fully ready and GraphQL engine successfully connected to my Yuga by DB managed cluster. The flight is normal. Let's move forward and create schema and load the data using similar Hasura command that we previously applied for Amazon Aurora. Okay. Schema is loading, guys. Everything is fine. So like the application we're able to create all the tables, stored procedures and triggers. Now we are loading the data. Also, it will take a minute or so, same as with Aurora. All right, the data is loaded in my Yuga by DB cluster. Let's quickly validate that that's the case. That's Aurora. Let's check the same relations. All right, the app is here. And the final verification, I want to open this app and check that it would be able to connect to my Yuga by DB managed cluster. Same as with Aurora, and during the first request to this Next.js application, the application will compile your code. So the first launch is a little bit slow, but once you're here, you can see the same products and catalogs. Right, that's the runtime compatibility in action. We will easily, without any issues, migrate from open source Postgres to Aurora and Yuga by DB. And the difference between the last two is that Yuga by DB is a distributed, geo-distributed database that scales both reads and writes, while Amazon Aurora scales only reads with its read replicas. All right, hope this is useful for you. And remember one thing, that the only 100% compatible database with Postgres is Postgres itself. Good luck.